Hi again, and welcome back to our Elements Superheroes Lockdown Special. And today we're going to be looking at our next element running down the alkaline metals, Rubidium, which is a name that a lot of people have not heard of. The elements above it, much more common, starting to get a little bit weirder as we go down the table. So let's pull up the card. Now, it's one of the alkaline metal, which you remember is a soft silvery metal that will explode and burn with this fantastic red flame if it's put in water. And if you look at its atomic number, is 37. So let's pull up a quick pic of rubidium. Now 37, that means 37 protons in its center, held together by 37 neutrons and 37 electrons whizzing around the outside. So it's getting busy. It's getting heavier. Its mass is increasing. That's why he takes up more space on the card. And it's finally at rubidium, if you put it in water, it's heavy enough to sink in the water. The ones above it are lighter and they'll all float on the surface of the water, but not rubidium. And I'm pleased with this one. It's got a sensible atomic symbol, Rb, for rubidium. Now, rubidium was discovered in 1861 by Bunsen and Kirchhoff, two German chemists, and they noticed this red colour that appeared when you burnt rubidium. In fact, they started noticing that if you burnt a lot of the different elements, you'll get a different colour that's unique to that element. And then when they saw that colour red, they were to use a prism. Here's a prism. This is just a triangular piece of clear glass, and that would break up the colour red into all its different wavelengths. Now, you're used to this when you see a rainbow. Raindrops act as a prism. Light strikes through it, bounce around, splits it, and you get the beautiful rainbow. Now that the colours of the rainbow are the colours of pure white light. But these elements produce different colours in their spectrum. Now this opened up a whole new branch of science, spectroscopy, tricky to say, and they were able to discover other elements, but most exciting of all is they were able to have a look at our own sun and analyse what elements were in it by looking at the various colours. And they discovered, the first thing they discovered was sodium was in our sun. And that burns with a sort of yellowy orange flame. I've tried to put the colours of the various elements as they burn in this group. And it's quite poignant at the moment. I'm talking about a rainbow because at the moment that's chosen as the symbol to support our NHS, who are out there at the moment doing an incredible job. Thank you to all of them. So, rubidium, in the last video I said it was cool. Why cool? Well, if you look at the top of the card, we've got these icicles. Now, rubidium holds pretty much the world record for being the coldest thing we've ever managed to make in the universe. They've got it down to nearly absolute 0 Kelvin, which means the lowest temperature you can go. Now, why were they doing this? Well, here's a new concept. I said he was cool, and this is why. There was a very intelligent Indian guy called Bose, a very intelligent German guy called Einstein, and Bose came up with a theory, an idea, that there was another state of matter. Okay, let's go through the states of matters. Now, the 3 states of matter everybody is familiar with: solid, liquid, and a gas. Now, the solid is when things are cooler. You have solid metal, like iron, solid iron, but it will turn into a liquid if you heat it up enough. It begins to break its bonds, because all heat is is when atoms vibrate. And the faster they vibrate, the hotter something is, the more energy it's got, it's more excited. But there's more than these three states. So you've got solid, a liquid and a gas. And then you have, beyond the gas, where it gets really hot, you have something called plasma. That's where things really fall apart. Our sun is a big ball of plasma. You're looking at a giant ball of plasma there. But what happens if you go in the other direction? If you get colder, is there anything beyond a solid? Now, you don't really have to... It's really tricky what I'm about to tell you, but I'm going to give it a shot. Now, there was a thing called a Bose-Einstein condensate. Now, what does that all mean? And I've watched a load of videos on it, and it's still tricky to understand, but I'm going to go for it. Now, a Bose-Einstein condensate is where you get so cold that the wavelengths of the atoms begin to overlap and all work together. And it's called a superatom when it gets to that low, which is quite cool because these are superheroes, and that is our superatom. And what's it used for? Why are they doing this? Well, I mean, it's scientific research into all sorts of branches, but a thing called quantum computing is a possibility. In quantum computing are computers which can work thousands of times faster than our fastest computers now. So that's fantastic as well. So all sorts of research into this Bose-Einstein condensate. So there's 5 states of matter. The condensate, you've got then the solid, liquid, gas, and then plasma. Now, incidentally, the name rubidium comes from rubidus, which is a Latin word, which means a deep red, because of the red colour that they discovered in the spectrum. Here it is, this is spectrum. Notice that really deep red colour, and because it burns that fantastic deep red colour when you put it into a flame test. And then finally, up in the corner, can you see this? Up in the corner here, we've got a spaceship. What's that doing there? Right. Have you ever heard of an ion drive? Now, rocket. Here we have rocket, space rocket. Now, all space rockets, when they take off, they burn some kind of fuel, usually a liquid oxygen, liquid hydrogen, and they need that massive kick of energy to get into space, to leave the Earth's gravitational field. You need a real kick, but they're super inefficient and they're super heavy. They make a lot of noise as well. But once they're up in space, there is another method of propulsion, and they use rubidium, which is over here, and xenon. You notice the blue pulses coming out of her hands, as a fuel for a thing called an ion drive. What on earth is that? Well, very basically, if you look, here's an atom. These electrons, they're not fixed forever around the atom. They can actually wander off doing crazy things, hence electricity. And you can add or take away certain electrons from this. And if you do that, it's called an ion drive. So there's your ion, and then in a chamber on the back of the spaceship, they have a very clever bit of equipment, basically run by solar powered cells, which gives us electricity, and they use magnetism and do all sorts to these ions, but basically spit them out of the back of the engine. And so Isaac Newton's law of every action has an equal and an opposite. Well, if you spit them out that way, the spaceship will move that way. Now, it's very slow. It's acceleration. It's not like a rocket, but using rubidium or xenon and using this ion drive, you can slowly accelerate a spaceship to incredible speeds, because a normal rocket, the fuel comes out at about 9 kilometers per second, whereas rubidium or xenon, much faster, many times faster. And in NASA, they've had an ion propulsion drive going continuously for 5 years. It just doesn't stop. It's very efficient. So there you have it, rubidium, an element not many people have heard of, but a very cool element because it is a super element. Once it gets cold enough, it turns into this Bose-Einstein condensate, so that can lead on to quantum computing. It's showing new ways to travel through space using ion drives, and Rubidium, discovered by Bunsen and Kirchhoff, don't forget, opened up the new way of being able to analyse what elements are on various suns. So, thanks for joining us again. Next video will be about cesium. And with cesium, I'm going to show you how that you are a time traveller. Okay, see you next time.